So this is your last chapter, chapter 10. Chapter 10, we are going to get into matrices. But before we do that, we have to talk about systems of equations, because matrices are going to involve systems of equations. And today, we're going to learn how to solve a linear system with 3 variables. You're used to solving systems with 2 variables. That's something that you should have learned in Algebra 1. So we talked about the 3 methods. The first method we talked about was graphing. So when you are graphing, how are you finding your solution? Well, what part of the graph is your solution? The intersection, right? The point of intersection. So when you're graphing, you're trying to find the point of intersection. So your solution is the point of intersection. So a lot of times we do this with our calculator, and we use the intersection feature. Right? Your chapter 10 test will have a calculator and a no calculator portion. So today we will not be using our calculator. The second method is substitution. This is a popular method. When you do substitution, what happens is you end up solving an equation for one variable then you substitute the expression into the second equation to solve. Now, it's common to use substitution when you have a variable that has a coefficient of 1. Right? We are going to be using some substitution, but the main one we're going to use is elimination. Can anybody tell me what your purpose is when you're doing elimination? What's your goal? How do you eliminate the variable? Yeah.
Okay. Well, it sounds stupid, but I think it's when you make one value cancel out the other value.
Exactly.
And then you add
The equations together, yeah. So when you add the 2 equations together, you want the variable, you want the coefficients to cancel out, which means what's the relationship between those 2 coefficients? Yeah, they're opposites. Good, okay? Now, sometimes we have to multiply to get these. Sometimes they're already going to be there. So we're going to multiply to get opposite coefficients. If needed. So sometimes they're already opposites, which works out nicely. Then you add the 2 equations together. When you do that, when you add the 2 equations together, you're solving for a variable. And then how do you find the other variable? You have to plug the other one back in. Okay, so that's always your second step for both of these. So we're going to briefly describe what these systems look like in a graphic representation. So graphically, you can see this intersects at one point. So these are going to be intersecting lines. And intersecting lines are going to have exactly one solution. Okay, that solution is in the form x comma y. Every solution is going to be a point. Now, what type of lines are these? Parallel. So we have parallel lines, and parallel lines have what type of solution? No solution. And we have another word for this. So if you have parallel lines, they have no solution. And what we do is we call this inconsistent. Okay, so we have parallel lines. Those have no solution. And then we call that type of system inconsistent. Okay, and then the last one has one line. Why is that? Yeah, the lines are overlapping. Do you guys remember what mathematical word we use for that? Coinciding. So they're coinciding lines. Okay, they are the same line. And coinciding lines have how many solutions, you think? Infinitely many, yes. Okay, and then we call this system dependent. Okay, so if there's no solution, it's inconsistent. If there's infinitely many, we call it dependent. If they're intersecting lines, you're actually going to have a solution, so you don't have to say what it is. But this would be classified as consistent and independent. So pretty much the opposite of these two, right? It's not inconsistent, it's consistent. It's not dependent, it's independent. Okay? You won't have to write that necessarily. All right, so the last thing we want to talk about before we get into solving three variables is solving with two variables. So what we're going to do is we're going to use elimination to solve systems of equations, and we're going to use this technique to solve the systems of equations below. Now this is something that you've done before, so if you can do all of those, you can go ahead and work ahead of me for that. I'm going to walk you through the first couple, and then I'll have you do the last one by yourself. So remember, with elimination, we want opposite coefficients. So if I look at my x's, are those opposites? No. Okay, what about y's? Yeah, so see how I already have an opposite pair of variables? So if I already have that, then all I have to do is add my two equations together. So because I already have opposite coefficients, I'm going to add the equations. Okay, so already have opposite coefficients, so add the equations. Okay, so if I add these together, 2x minus 3y equals 9 plus 4x plus 3y equals 9. Just going to add my like terms, so I have 6x equals 9 plus 9 is 18. So then to solve for x, I divide both sides by 6, and I would get x is equal to 3. Okay, now to find y, I can substitute x into either one of those. It doesn't matter which one. So I have 2 times 3 minus 3y equals 9. 2 times 3 is 6, so I'm going to subtract 6 from both sides. I'll get negative 3y equals 3. And then y is going to equal negative 1. And then you're always going to write your solution as a point. So this will be 3, negative 1. Okay, and then once you have your solution, if you plug it back in, both statements should be true. So 2 times 3 is 6. A negative times a negative is a positive, so this would become plus 3. 6 plus 3 is 9. Yes. 4 times 3 is 12. 12 minus 3 when I multiply by negative 1 is going to be 9. Yes. Okay, so I know that those work for both. Okay, on the SAT, there's always a system of equations somewhere. Okay, so this is something that we really need to make sure we have down. For B, I don't have opposites, so I can choose. Do I want to cancel out the S's or do I want to cancel out the T's? What do you guys think? Yeah, the T's are going to have a smaller LCD. So between 3 and 2, what's my LCD? 6. So what are we going to multiply the top equation by? Okay, so if we multiply the top equation by 2, this is what I do. I just put a little swoop and then I rewrite it. So 2 times 8 is 16 minus 6t equals negative 6. Don't forget, you do have to multiply everything by 2, including that negative 3. And then what about the bottom? What am I going to multiply that by? It has to be negative 3, right? Because you have to have opposites. And if you just multiplied by 3, they wouldn't be opposites. What would they be? They'd be the exact same. Okay, so now I'm going to add these together. 16 minus 15 is 1, so I have 1s. Those are going to cancel. Negative 6 plus 3 is negative 3. So my s value is negative 3. So then I can substitute. This time I'll use the bottom equation, because it really doesn't matter which one you use to solve. So I have negative 15 minus 2t equals negative 1. So I'm going to add 15 to both sides, which is going to give me negative 2t equal to 14. So when I divide by negative 2, I will get t equal to negative 7. When you're writing out your solution, it's always alphabetical. Okay, so st will be negative 3, negative 7. Right? And then we can always plug it back in to check. So negative 24 plus 21 is going to be negative 3. Yes. Negative 15 plus 14 is negative 1. Yes. Okay, so it works for both of them. Okay, so go ahead and do part C. Okay, so what did we decide would be the quickest way to eliminate a variable here? Well, if this is 9, how do I get negative 9? Multiply by 3, right? So if I multiply by 3, I have negative 9x plus 15y equals 6. And then on the bottom, I have 9x minus 15y equals 6. Now, something special happens here, right? This is going to be 0. This is going to be 0. What's 6 plus 6? 12. Make sure you put 12 and not 0, because those will be two different situations. When you're left with an equation such as 0 equals 12, you just have to ask yourself, is this true or not true? Does 0 equal 12? Obviously not. So if it's not true, then there's no solution. Okay, and we say the system is inconsistent. Okay, I just want you to know if you did have 0 was equal to 0, see how that's true? So if that was a negative 6, this would be a true statement. Then there are infinitely many solutions. Okay, so if you get cancellations with both variables and the statement is not true, it's inconsistent. If it is true, then there's infinitely many solutions, and then we call that dependent. Okay, questions for me so far? Okay, so you learned how to solve a system of equations with two variables in Algebra 1. Now we're going to learn how to solve a system of equations with three variables. So in example 1, our next example, what we're going to do is use a method that is called back substitution. And you're going to really like back substitution because it's pretty simple to execute. So we can use this whenever a system is in what we call triangular form. Okay, so when it's in triangular form. And our next system is. Right, we say it's in triangular form because these make a triangle. Your variables here. Can you guys see I made a triangle out of those? Right, so when you are solving, it's really nice because see how you already have what z is equal to? Z is equal to 3. What you're going to end up doing is solving this in reverse order. So the first thing you're going to find is z. The next variable you're going to find is y. So because you know z is 3, what can you do with that? Plug it into the second equation. So you have y plus 4 times z, so I'm going to plug in 3 equals 8. So this would be y plus 12 is equal to 8, so I'm going to subtract 12 from both sides, and y is going to equal negative 4. And then I can take these two variables and plug them in where? Our top equation, so equation 1. So then I'm going to have x minus 5 times my y value, which is negative 4, minus 3, which is my z, equals 22. So this is x plus 20 minus 3, or x plus 17. So what's the difference between 17 and 22? 5. Okay, and then again, still what you're going to do is write your solution as a point. So this would be 5, negative 4, 3. Okay, so if we think of this graphically, this would exist in what kind of plane? In a 3D plane, right? Which we graphed in chapter 9. Don't worry, you don't have to graph it. Okay, so back substitution is really nice, but you have to have that triangular form. When you can't use back substitution, solving the system becomes more complicated, but there are two main strategies we can use to help us solve. So the first strategy is to put your system in triangular form. Okay, just like we have the form in example 1. Okay, so when you're doing that, your goal is to get a system where you have an x, a y, and a z equal to some constant, equal to some number. And then you want a y and a z equal to some number. And then you just want a z equal to some number. Okay? Now your coefficients don't have to be 1. They can be anything. I just didn't want to use the whole alphabet to put those in there. Okay? So your goal would be to have x, y, z, y and z, and then z. And then see how that's going to create that triangle. You have x, y, z, you have y, z, and then you have z. And that's when you can solve for your triangular system. Okay, and then for strategy 2, what you would do is eliminate one variable from all three equations. Okay, and you can pick which variable you want to use. Right, so because we have two strategies, we're going to do two examples, an example 2, part A and part B. And for part A, we're going to use strategy 1. For part B, we're going to use strategy 2. Okay, so strategy 1 is to put this in triangular form. Okay, and I've listed the steps here for you, so you can follow those pretty quickly. So it says your first step is to eliminate x from equation 2. Now, in order to do that, you can pick equation 2 and either equation 1 or equation 3. But I always just do the first two equations just because I try to keep it consistent. You have a lot of different choices, but you'll see when I do it, I just automatically take the first equation and the second equation. So the first equation is x minus 2y plus 3z equals 1. And then the second one is x plus 2y minus z equals 13. Now, before we eliminate x, I just want to point something out to you. If I were to add these together, what variable would I naturally eliminate? Y. So it might be a good choice if something like this showed up on your homework to do strategy 2, and what would be the variable I would eliminate from everything? Y, because they'd automatically cancel out. Okay, but you can do either strategy with any system that you have. Okay, so we're choosing to do the first strategy, so I'm going to eliminate x from equation 2. So in order to do that, I have x and x. What am I going to have to multiply by? Negative 1. And again, you can choose what equation you want to multiply by negative 1. So I'm multiplying the first equation by negative 1. If you wanted, you could multiply the second one by negative 1. And my equation 2 is going to stay the same here. And then I'm just going to add those together. So my x's are going to cancel out. I'll have 4y minus 4z equals 13 minus 1 is going to be 12. Now, because we're eliminating x from equation 2, this is going to be our new equation 2. Okay, so what that means is we have transformed our original system. Okay, so the first equation is the same, but our second equation we just transformed. Okay, so we eliminated it from equation 2, so this is my new equation 2. Now my third equation hasn't changed yet. Alright, now if I look at my system, can we see that the first equation and the second equation are now in what they need to be for triangular form? The first equation has x, y, z. The second equation just has y and z. So then what am I going to do next? Well, what do I have to do to the third equation? If I'm putting the third equation in triangular form, what's the only variable I should have in the third equation? I should only have z, right? So I have to eliminate the x and I have to eliminate the y. Alright, so the first thing we'll do is work on eliminating the x from equation 3. Okay, so I'm going to eliminate the x. So in order to do that, because I'm working with equation 3, I definitely want to have equation 3 in there. And then I'm also just going to use my first equation. So equation 1 is x minus 2y plus 3z equals 1. My third equation is 2x plus 4y minus 7z equals 1. Okay, and then JC, if I want to cancel out my x's, what am I going to have to do? Good, so I'm going to multiply the top equation by negative 2. So that's going to give me negative 2x plus 4y minus 6z is equal to negative 2. And my equation 3 is just going to stay the same, and I'm going to add these together. Usually the mistakes come when people start adding them together. 4 plus 4 is 8. Negative 6 minus 7 is negative 13. This will be negative 1. Okay, so if we want to check in with how our system is, what we've done now is replaced equation 3. So equation 1 is the same. Equation 2 is the same from our previous step. But this is our new equation 3. The only problem is equation 3 still isn't in the form that we want it in because we don't want the y. So now we're going to eliminate y from equation 3. Now if we're going to eliminate the y, you only have one choice of what equations to choose. Which ones are we going to use for this?
2 and 3.
Yeah, we have to use 2 and 3. Why? It's because you have your 2 variables, right? If you had 3 variables, you wouldn't be able to solve for one of them. And so you have to take equation 2 and equation 3. Okay, and that's our new equation 2 in our new system here. That's our new equation 3. So not the ones originally given to us. Okay, so you really need to make sure that you're being careful when you're adding these together, because obviously if something went wrong in this step and then you were using the wrong equation here, you'd have a lot of things that were not in the correct order. All right, so if I want to eliminate y, Josh, what am I going to do here to do that? Close? Yes, okay, good. So you're going to multiply the top by negative 2, so you want it to be the opposite of 8, which would be negative 8. So now I have negative 8y plus 8z equals negative 24. My bottom equation is staying the same. So 8 minus 13 is negative 5. Negative 24 minus 1 is negative 25. Okay, and your z value will be 5. Okay, so what that does is it creates your triangular system. And I'm going to put this here. Okay, so your triangular system. Is that Dylan?
No, that's JC.
Okay, so then your first equation is x minus 2y plus 3z equals 1. This is your new equation 3 that you just found, just that z. Okay, so x minus 2y plus 3z equals 1. Your second equation is still 4y minus 4z equals 12. And then your last one is z equals 5. So we have our triangular system. What's the benefit of having the triangular system? And what do we call that? What kind? Back substitution. Okay, so now we can use, and this will be our step 4 for this, is use your back So we already know that z is 5, so 4y minus 4 times 5 equals 12. We can see this is going to be negative 20, right? So it's okay if I just add 20 here. So 4y would equal 32. When I divide by 4, I would get 8. Okay, and then in my last one, I have x minus 2 times y plus 3 times z equals 1. So x minus 16 plus 15 equals 1. This is a negative 1, negative 16 plus 15. And then I have to add the 1 over, so this is 2. Like I said, it's problems like this where people just mess up on the small things. Like you see negative 1 and 1, and then you start adding it in your head because you're going fast, right? And then you think 0. But no, make sure that you are being careful, either writing out your steps or using your mental math. So then your solution is going to be 2, 8, 5. Okay, and that's strategy 1. So that's triangular form. So now we're going to do strategy 2. Sorry. Do you guys need any more time with that? Okay, so now we're going to do part B. So for part B, I'm going to give you what your system is. So we have the fancy bracket, and then x plus 7y minus 7z is equal to 3. 3x plus 14y minus 16z is equal to 17. And then 2x plus 7y minus 9z is equal to 10. Okay, and then for this one, we are going to use strategy 2. And in strategy 2, we're going to eliminate a variable from all equations. Now, you can pick which variable. Which one is definitely one I would not pick for this system? Yeah, Z. Because look at the other ones. See how their LCDs are going to be a lot lower? Here and here, right? These are multiples of 14. Here you just have 1x, which will be really nice. What I'm going to do is I'm going to eliminate x from 2 equations, and then I have to eliminate x from 2 different equations. Now again, you can pick any 2 equations to start with. So if you wanted to start with 2 and 3, you could do that. I just always start with 1 and 2 because I do it in a systematic fashion. So if I'm going to use equation 1 and equation 2 here, I just have to use 2 different ones. So sometimes I use equation 1 and equation 3. Other times I'll do equation 2 and equation 3. It honestly doesn't matter as long as it's not equation 1 and 2 again. Okay, so they just have to be 2 different equations. Alright, so if I'm going to eliminate x from the first 2 equations, let's look at what I got. So I have x plus 7y minus 7z equals 3, and 3x plus 14y minus 16z equals 17. So because I've chosen to eliminate the x's, if this is 3x, what do I want this coefficient to be? Negative 3. So I'm going to have to multiply everything in equation 1 by negative 3. And I'll write the result down here. So negative 3x minus 21y plus 21z equals negative 9. And then I'm going to keep equation 2 the same. Okay, sometimes you might have to multiply both equations by something, and that's fine too. Right, so what's the difference between 14 and 21? 7, so this is going to be negative 7 because the 21 is negative. When I'm doing that in my head, I count up to the whole numbers. Like I know if I add 6, I get to 20, and then one more to get to 21. Same thing here. The difference between 21 and 16 is going to be what? 5, and then this one will be positive, so plus 5z. And then negative 9 and 17, you can think of it as 17 minus 9, which is going to be what? 8. So this is your new equation, and we're creating 2 new equations. I'm just going to call this new equation number 1. Okay, I'm not going to plug it back into the system because I'm not trying to set up something that's triangular. This is a different strategy. So now I'm going to eliminate x from 2 different equations. So I chose equation 1 and equation 3. And again, I'll just let you know that if you wanted to do equation 2 and equation 3, that would be perfectly fine. Okay, so remember I'm eliminating x. So I want you to multiply by what you need to multiply by and then add those together. Okay, and Henry, what did you choose to multiply by for this? Good, okay, so we multiply by negative 2. So we have negative 2x minus 14y plus 14z equals negative 6. And then the second one's going to stay the same. So we're going to add these together. No calculator. Okay, so this will be negative 7. 14 minus 9 is 5. And this will be 4. Okay, so this is your new equation number 2. Right? Now, what you've done is you created a system where you just have 2 variables. So now what we're going to do is we're going to take this new system and solve for the variables just like we did on the very first page. Okay, so you're going to solve your new system. So your new system has the 2 variables that we created in the first and second steps. So when you solve that system, you're going to get what variables? You're going to solve for what variables? Y and z, which means then we're going to have to use substitution into any of the original equations, and then we would find the variable that we eliminated, which was x. Okay, so your new system is going to be negative 7y plus 5z equals 8, and negative 7y plus 5z equals 4. Okay, so if I want to cancel out the y's, I can multiply the top equation by what value? Has to be negative 1. Okay, so then I'd have 7y minus 5z equals negative 8. On the bottom, I have negative 7y plus 5z equals 4. And then something special happens. Negative 8 plus 4 is negative 4. Is this a true statement? No. Okay, so if it's not true, okay, then there's no solution, and then we say that it's inconsistent. Right? In your directions, it says find the complete solution of the linear system or show that it's inconsistent, so that's how you're showing that it's inconsistent. Okay? If you did solve, okay, then you would find y and z and then plug y and z into an original equation to find out what x is.
On the homework,
Yep.
so I kind
to show that it's inconsistent. So what I'll specifically be looking for is this equation. Okay, so I still want to show it's inconsistent, you have to show that it's going to result in an equation that's not true. Okay, so I'd still expect you to have 0 equals some value. Okay, and then just as a reminder, if all of your variables are eliminated, okay, like what just happened in part B, I put eliminated, aided. You guys know you're the first class to get well, the first year. Eliminated. You're the first year to get note guides. Last year we did them on sheets of paper like this. You're very blessed. Okay, so if you have a true statement such as 0 equals 0, then there's infinitely many solutions. And we say that the system is dependent. Okay, if you have a false statement, such as what we had in our last one, 0 equals -4, then there are no real solutions, and we say the system is inconsistent. Okay, so I'm asking you to do 6 problems for homework, and I'm going to give you some time to get started on this. So you're going to do 8, 13, and then 17 through 23 odds. Okay, and all of this is going to be no calculator. Right, and then I'll actually put the book up here in just